Uh, yeah, let me open up that IS code. Just give me a minute. Yeah, can you see my screen? Hello, Rishabh sir.
Yes, yes, I'm able to see yes.
Okay. So basically, this is a table for K1 values for different design life of the structures. So earlier we took a value of 100-year design life, but after we went to thorough review, so we found out like the design of the structure is between 5 to 10 years. So for 5 years, the K1 value is 0.76. For 25 years, K1 value is 0.92. So if we interpolate for the same, so we'll get the value of zero point 0.8. So that's why we went for the zero point 0.8 value.
Suppose there might be any point for interpolation is possible for any value between it, or you should for the maximum value for it. Any note for it?
So usually for such cases we do linear interpolation. So let's say
If the value
if I'm considering 10-year, yeah, tell me.
that if that the values are having a distribution linearly, a linear distribution, then you can go for linear interpolation. If the distribution is not linear,
Mhm.
then we cannot go for linear interpolation. In that case, we just have to go for the maximum value. 5 to 10 years, you should take the value for mean
Mhm.
life of 25. Will that be possible? I suppose your user won't have any problem because of that. Even if you take it for 25, that will come at around 0.92, right? Even if you do that
Mhm.
today, I
Mhm.
suppose your structure will not be having any. Wind is not a critical point over here. You just varnish it properly and submit it.
No, sir. Matlab, usually we do like this. So we haven't faced such problem like that as of now.
So what I'm trying to say over here is your structure is critical because of this 5 years and 25 years. Go for the 5 years. My justification for it will be the class of structure serial number 2 in this table. That is serial number 2 is for temporary structures,
Mhm.
such as those used during construction operations.
Right.
Yes, if you read it properly, this is a building or structure presenting a low degree of hazard in
Mhm.
event of failure. So even if you, for that case, if you take 0.92,
Mhm.
reasonably safe.
Okay, sir, if you want us to go for 0.92, we can go, sir. There won't be any problem from us.
There won't be any
But
problem. That is my point.
yeah, there won't be any problem. The only issue is it will take some time again. And what we were planning to close this thing today only. Am I right,
Okay, to
Tejas?
close today itself, actually, I will have to add someone else from my team. Then.
Yeah, sure.
Okay, you may continue. I'll just.
Okay. So going for the terrain roughness, we went for the open ground for K3. We took the generic value because there are no nearby steep slopes. So we took the generic values of K2 and K3. Okay. Now coming on
K2 and
to the
K3 you took
reduction
as.
factor that we have mentioned earlier. Vishal, can you please share your screen again?
Is the screen visible?
Yeah.
Acha, Agrawalji, can you help me with one thing, please?
Yeah, tell me.
Hello.
Yeah, yeah. Tell me, Rishabh.
One of our supervisor are trying to join. Can you send me the link for this?
Harsh, can you please forward the link?
Okay, sir.
Mm.
Hello.
Hello.
Yeah, Rishabh, tell me.
Yeah, you may proceed.
Hello, Girdhar ji.
One more thing regarding this topography factor A3.
Pardon?
Topography factor A3.
Okay, right. So what happens in topography factor, as I understand, is if there is any nearby slope uh, less than 3 degrees, we can take K3 value of 1, and if the angle is more than 3 degrees, we can go beyond. We'll have to take K3 value more than 1. So in our scenario, I think water is has 0 degree slope. So in that case, we went for 1 only.
That is one parameter. Another one is K3 is taken maximum at your ground level. Minimum, then you have to take one for higher levels.
How much?
6 and 5. Okay, okay,
Yeah, continue, Rishabh.
okay, okay. Okay, we may proceed with the next point, please.
Okay. So yeah, Vishal, you can continue. Vishal, you are not audible. Turn on your mic. I think there is some mic issue from Vishal's side. So regarding second point, anchor design should be revised. Anchor design should be revised as per new wind calculations. So as we mentioned in point one, like wind calculations are accurate. There was only one typing error, and we have corrected that. So since the calculation is correct, we don't need to change anchoring calculation as well. So I think uh, we are good with second point. Now coming to third point, I think Vishal is back.
Yes, sir. Am I audible now?
Yes, yes, continue.
Yeah. The third point is this in fully loading condition, the load of three people standing on the edge of the pontoon is considered in calculation of heeling moment, although the same shall not be considered in calculation of righting moment. So I was not very clear about this point. So if You can elaborate on that. What is meant by that?
What you have done in your design is you have calculated the total weight of the structure.
Right.
0.042 tons, right?
Yes.
Here you have taken the load of three people.
In the weight calculation, weight is there.
Taken,
The
right?
weight of the three people. Yeah.
So what I'm trying to tell you is now this total load calculation has been used the same for healing moment calculations.
So the healing moment has been calculated by using the weight of the uh, particulars which is loaded off center of the center line. So this includes weight of three people and the pipe and the winches. So these three things has been placed which is off center. So the distance from the center line multiplied with the weight gives us the total volume, total moment that is in ton meter. So that is the total healing moment I have calculated here
Right.
in both the along both the axes.
What is the case with the writing moment as I am having a problem?
So writing moment is the property of the water plane area. So water plane area of the pontoon that is resisting this healing moment in both the direction. So that has been calculated. It is basically calculated with the GM value, that is the metacentric height, and metacentric height multiplied by with so it
Displaced weight, right? So in
yeah,
this
yeah.
displaced weight, we should not take the weight of the three.
In this displacement the weight of the people would be there because it is there and it is helping in lightening the ship, the pontoon. It would be there. uh,
People are on the edge of the pontoon, then how will they? If you can just
No,
yes, yes.
clarify things for me.
actually, I'll just simplify it. Let's
Okay.
just assume a cantilever beam, Rishabh. So what happens in cantilever beam? Let me just take an example. Let's assume this one is cantilever beam and I am holding it from one side. So whenever I am putting in a load at this end, what it will does, it will create a moment about this point. That is one
Right.
thing. Along
Right.
with that, it will create a shear force along this
Right.
section, and ultimately the shear force will go to this connection. So what is happening is, due to one force we have shear, load and bending moment. Same is happening here. If three people are standing on the edge of the pontoon, they will apply a vertical force, so it will ultimately affect the buoyancy. That's why we have considered the load of three peoples in the buoyancy calculation, and along with that we have calculated movement along its center for the tilt evaluation purpose.
Right. So healing moment. I had only the point about writing moment being
So writing movement is
without
basically
three people
right.
because they've already been considered in the healing moment.
No, so writing movement is independent of these loadings. Writing movement is
Writing sir, yes. So
writing
writing
movement.
moment.
Yeah, continue, Vishal.
So writing moment is independent of the loading, like the center of gravity. Even if it is that transfer center of gravity is high or it is low, it does not matter. Only the weight of the whole system is what is going to give us the what we are going to take as a displacement. So whole system as a whole, it will have a center of gravity, and through that center of gravity, this it will apply a moment that will be the writing moment. So in
What
that,
I suppose is for your writing moment, you should take the geometric GM, multiply it by your displaced weight, right?
Hello.
Yeah, now audible.
Yes, yes.
Now you are audible.
So
So
I will give
taking
you
your
one example. Sorry. Hello.
Yeah, Vishal, we can hear you.
Yeah, I'll show it with a example. So let's say we have a uh, cross section of the pontoon like this,
okay,
and its center of gravity is here initially at the center. And let's say we apply a load here, which is off center. So this center of gravity will shift to a new point. So what will happen now is this total displacement will act through this point.
hello.
So yes, yes.
You are not
So the
audible for the last few seconds.
so what I'm saying is, let's say we have a pontoon which with center of gravity at the center of the geometry, and then we add a weight which is off center. So this will shift our center of gravity to a new point.
Right.
So what will happen is this and our buoyancy force will act upwards.
Right.
So what we do is we calculate the perpendicular distance from the line of center of buoyancy force to the line of action of gravity force, and that perpendicular distance is gz, that is the writing lever. So if ship is in upright condition and there is no list or heel, so gz is zero, so there is no writing moment. But even if we apply put a load which is off center and it is giving a healing moment, it is again a part of this total w, total weight of the, this final weight will be part of like it will contain both of the weight. So this new g, it will only change the line of action of gravity force, but it will not change the value will again will be the total weight of the system.
Okay.
And again, Rishabh, if we, matlab, from our perspective, I think the calculation procedure is right. And even if what you are suggesting, like we should exclude the weight of three people, it will only increase the value of rightening moment, and which will make or it will look our structure more stable.
That's true.
Okay. But as per our understanding, this procedure is correct. Uh, and if we remove the weight of those people from writing moment calculation, it will increase the factor of safety. So I think it's
If you
not an
can,
issue.
if you can make it that way, then it will be. Can make it that
Uh,
way. It is better for.
Vishal, what do you suggest? I think Vishal is an expert here. So
Sir, I'm 100% sure that this total weight will act as a moment, writing moment, not the even if it is off center, it does not matter. Whole weight will give the writing moment.
okay.
Yeah.
So Rishabh sir, please suggest us like what should we do?
Give me a minute. Hello.
Yeah, hello.
Can we continue with the next one?
Okay. Vishal, can you please share your screen?
Yes. So the next point is this: as per your calculation, the second moment of area in table 7, that is for uh, fully loaded condition, it does not match with the calculated second moment of area for damage stability. So it is like we have informed in the report that one floater we have considered that it has been punctured. So when we calculate the second moment
Okay.
of area is of the water plane. So when we consider one floater as punctured, we will not consider its area in the calculation of second moment of area. So that why it is lesser.
You can take its whole second moment of area, including the second moment of area of the damaged floater, and then you can include it, the weight of
No,
the
but
water inside it as well. That is one method of doing it.
yeah, that is so there are two methods. One is added weight method, and one is lost buoyancy method. So we can follow any one, but it will not change our calculation.
We should follow the method which is giving the most critical results.
It
What I
is actually I have yes. So what I have done is I have added the weight of the water that will be added as a volume in the punctured floater. I have removed its buoyancy, and I have removed the water plane area of the pontoon. So that will be the most critical situation.
Basically, we added both of the scenarios. We added the lowest buoyancy method with added mass method. So we went for the critical one, the most critical one scenario in this case.
So,
okay, thank you. Next.
Uh, Rishabh ji, I cannot hear you.
Hello.
Yeah,
Yes, please, we can proceed with the next one.
okay.
so should I go ahead with the next point?
Please.
Hello.
Yes, Vishal, we can continue.
Okay. So the next point also is for light ship condition in which maximum tilt angle of the pontoon needs to be verified on account of discrepancy in the calculations. That also I could not understand, but again I've checked the values, and so for the light ship condition, yeah, here are the stability parameters. So maximum tilt angle is there. So I could not. It is correct. I don't know what is the doubt here.
Maximum tilt angle. Give me a minute.
Hello.
Yeah, Vishal, you can continue. Rishabh ji, do you want to add something?
It's one of my engineer. He has some points regarding your maximum tilt angle and its calculation.
Yes, yes,
Just give me a minute.
yes, yes. Please go ahead and tell.
Privacy. Hello.
Hello.
Yes, I'm audible.
Yes,
So what we found out over here is they have done the calculations for your fully loaded condition maximum tilt angle of the point. So for fully loaded condition, it is coming as 4.1 increase,
okay. Fully loaded condition. 4.13.
right?
Yes, yes.
So how does it change so drastically for your light shift condition? Can you please justify or shed some light on this?
Yes, yes. So as we can see here, the weight that we have considered for fully loaded condition, total weight load is 2.04 ton, and for light ship condition it is 1.25. So that is nearly around 60%.
The
Hello.
margins change due to this.
So what will happen is the draft will change here. So draft is very low in light ship condition.
Okay.
So when the draft changes, so this maximum tilt angle is maximum allowed tilt angle when
Tilt,
the
right.
when the top of the deck is immersed. So when we have lesser draft, this angle will increase. So it's just a 10 theta of the half of the breadth and the freeboard. So as the freeboard increases, this angle of tilt will increase.
Is it
Rishabh ji, do you want to add something to this?
no, I'll later on. You can proceed, please. Take the next point, please.
Okay, I'll cover these points.
Okay.
The second last point is the section sizes of the truss structure for the pontoon and its stress check, its complete stability report are not provided. I think we had a discussion in our first meeting, like you needed some structural detail of the gantry system or the gantry structure. So we provided you the same. We provided you the total manufacturing drawing of gantry structure.
But what I
Have you
have with
received
me
it?
are just some section sizes. Uh, what I wanted to know from that point is your gantry stable?
Sir, as per our internal analysis, it's stable.
देखिए अचिन जी होता कैसा है we cannot take your internal analysis in the picture while we are doing for some
Uh,
audit like this. If you, I gave this option to you as well in the last meeting, and also I gave this option to Tejasvi that if you do not want to share the details, it is completely fine with me. I want it vetted by some third party, preferably some government institute. In that case, Tejasvi told me that he'll take it from IIT.
right, sir. We had a discussion regarding this
तो
TPI.
उसके बारे में क्या हुआ फिर आगे तो नेक्स्ट टाइम भी
Uh,
आपने then you submitted it and it was not okay.
no,
So
no,
I
sir.
had to write that point again.
We are ready to provide you third party inspection for the same. But regarding its status, I think Tejas will be able to provide you proper feedback.
कि
Because in
it
order
is
to
very
do so,
critical.
we need approval from his side.
Point
Am
is,
I right, Harsh?
in my opinion, where I stand,
Yes, sir.
I feel it is very important that we understand ये सारा आपका tilt का calculation, then your depth of submersions and all of this uh, engineering thing, ocean engineering wala. I feel all of this will be viable once your structure is safe, once your structure is intact. Now, your truss
Right.
structure holding the whole pontoon into place. It is acting as the backbone of the whole
Mhm.
structure. If that fails or it yields at any point, the whole of the scenario, if I'm wrong, I guess.
No, no, you are absolutely right, Rishabh. We take care of the stability, and the most important part is the structural strength. So we take care of those things. So that is one thing. And the second thing is we are ready to provide you third party inspection. All we just need is approval from Teja's side. So other than that, it's all good. So I think
Rest all
Tejas
of our
is
points are,
not
I guess, covered and satisfactory, to be honest. Rest
okay.
assured, I'm not sure about what are you guys are doing about the stability report for the truss and for the gantry system.
Okay. Okay. So
But how do we take this forward? Because last time I suppose we had a talk some 2 weeks or 3 हफ्ता भी हो गया होगा जी.
I remember,
But
sir. I
told you
remember.
about this कि अगर नहीं है, if you don't want to share it, it is completely fine. But somebody outside your internal team should be able to. ऐसा है हमने खुद ने बनाया है तो खुद की
Hmm.
गलतियां खुद को तो you will not be able to find out your own
Obviously,
mistakes, right?
obviously, right, right.
So that is the requirement why government bodies go for someone as their authority engineer, someone as their independent engineer who is able to evaluate what is
Hmm.
happening
Hmm.
internally. इसलिए तो ये सारा प्रूफ चेकिंग और ये सब करते हैं, राइट?
No, no, sir.
वो
We
सब कुछ
provide
प्रोवाइड
that.
कर, आई विल बी
Just
मोर देन
give
हैप्पी.
us a minute. Okay. Harsh, can you please connect us with Tejas or Prashilji if you can add something in this regard? Just a minute, sir. We are updating you.
Okay, sir. 1 minute. I'm calling Tejas, sir. Achin sir, Tejas sir told that he will discuss in his management. Then after that, he will confirm us about the TPI.
Hello. हाँ ऋषभ जी, actually we had a conversation with Tejas ji. So right now he's not able to join the meeting as of now.
Okay.
And regarding this particular TPI point, uh, Tejas ji will update you shortly regarding this. Okay. Okay. So I think that's it from our side. If you want to add anything else.
Anything else? The rest is all assured. नहीं एक trust का और एक gantry का.
Okay. So I think the current stability report is good, right? There is only one correction, and we have made that.
Okay, right.
Okay. Thanks a lot, Rishabh sir.
Thanks to you.
Thanks a lot, Prashil ji.
If possible, इसका
Thank you,
कुछ
Vishal.
minutes अगर
Thank you,
आप
Harsh.
दे सकते हो तो you can please give it to me.
Okay, sure.
If somebody can prepare some minutes for this.
Sure, Rishabh will send you a minute regarding this.